Can you please confirm that if you can see my screen? Okay, thanks for the confirmation. Thank you for the confirmation. So, so we'll do a small recap. So in last session, we discussed about the literals topic, right? We discussed about the literals topic. So we discussed about char literals. We discussed about, okay, we discussed about char literals, Boolean literals. We discussed about integral literals, right? So we discussed about octal, okay, octal format, binary format, and we discussed about, hexadecimal format, and we discussed about decimal format, right? So how to convert them? So what are the rules and regulations of integral literals? So there are two literals that is left out. Also we discussed about floating point. We discussed about floating point literals. So if you want to represent the floating type data, right? If you want to represent the floating type data, so you must have to define f, small f or capital F at the end, small f or capital F at the end for the literal. Else it will treat it as double. It will treat as double. Reason is double is the default type for floating type data. Similarly, in integral literals, int is the default data type. Int is the default data type, right? So this is what we discussed. So we are left with two more literals, that is string literals, that is string literal, right? So we are left with string literals now, and we have one more literal, that is null literal, null literal. So these are simple topics which we will discuss about string literals and null literals. Then we'll move towards operators. Okay. So let us discuss about the string literals. String literals. Okay. So what is string literal? Okay. So how do we represent the string literals? How do we represent the string literals? So when it comes to the string literals, when it comes to strings, it is a huge topic that we'll discuss in the lang package. But for now, how do we represent strings? How do we represent strings? That we will talk about. For example, if I want to represent the string type data, string type data, string type data, then okay, then how do I represent it? So what is a string? String means a group of characters, string means a group of characters. For example, name of a person, name of a person, or it can be email id, it can be your email id, right? A group of characters. Okay, string string is simple to say a group of characters. So there are some rules and regulations for representing the string literals. What is that is string type data, string literals can be only stored in string literals can be only stored in string type string type reference data type. String is not string is not okay. It's not a primitive data type. It's a reference data type. It's a user defined data type. String is a user defined data type. So it's not a primitive data type. So string literals can be stored only in string type reference data type. And when you are representing the string literals, string literals must encode with double quote. Okay. So there should be a starting double quote and it should end with ending double quote. Okay, any characters that you write in between, that will be treated as a string, For example, when I say string means a group of characters. So name is the variable. So equal to Anil. So now you see it is starting with a double quote, ending with a double quote, and I am writing a group of characters in mid. I am writing a group of characters in mid. So this Anil is called a string literal. This Anil is called as a string literal. So there is one difference between char and string. What is that? Char will store only one single character. It will store only one single character, right? So which is enclosed with single quote. Char will be enclosed with single quote. Strings will be enclosed with double quotes. And you can write a group of characters, and you can have, and there is no length limit for string. There is no length limit for string. How many numbers you wanted to write, how much data you wanted to write, you can write it there. But it is always okay recommended or best practice is to have less okay, which is like 15 less than 15 characters we ask you to keep inside this double quotes. Okay, there is no length limit. By default, there is no length limit for any strings. And when you represent a string type data, internally your JVM will create it will create an array for it will create an array of characters. It will create an array of characters. So simple to say, string type literals can be stored in only in string type, reference type, string type, reference type, and there is no length limit. It has to be enclosed between single quotes. It has to be enclosed between double quotes. And internally, your JVM will create an array of characters, okay, inside the memory. So how it will store, we'll see it inside the memory. For example, in my case, I've taken name is equal to Anil. Name equal to Anil. So now what happens is, think this is your memory. This is the memory allotted for your JVM. And this is the division between the memories. Think that. So name is the name is the variable name, which means the name of the memory location. Name of the memory location. So inside name, Anil will be stored, right? So this is how we have treated for primitive type. For example, int age equal to 20. When I say this, so a age variable will be defined, and inside this 20 will be stored. 20 will be directly, the value will be stored inside this memory location. But in case of strings, it will not store the value directly. Okay, it will not store the value directly. So what happens in the case of strings? In case of strings, somewhere in the memory, we'll discuss what is that memory. Okay, somewhere inside the memory, a array will be created. A character array will be created. A char array will be created. Okay, so each character is stored in one specific index, something like this. Okay, so a character array will be stored. Assume that this address is 1234. This address will be stored here. This address will be stored here. Okay, this is what I mean by a character array will be created internally. Okay, so string literals will be enclosed in double quote. Okay, string literals will be enclosed in double quote. Only it can be assigned to string type data. It can be enclosed to string type data. And okay, the in case of strings, okay, the data is represented in the format of character array by the JVM. By the JVM. These are the rules. These are the rules. In case of string, not the actual values will not be stored inside it. Actual values will not be stored inside it. Okay, the actual value will be somewhere created as a character array in the memory, and that reference will be stored. That reference will be stored inside the name variable. Okay, so whenever I'm trying to print, or when I'm trying to use that, when I'm trying to print the name, or whenever I'm trying to use that name, okay, so now my JVM knows that, okay, here is the reference, this is the value, and it fetches that. Okay, there is much more about it. For now, just remember that string data can be written in enclosed in double quotes, and whenever, and you can only assign it to the string type data, and internally it will be stored inside as a character array. Internally it will store it as a char array. So that's all for the string type literals. Okay, so as I said, string is a reference data type. It is a reference data type, right? String is a reference data type. Now you see the actual value is not stored here. The actual value is Anil. Okay, actual value is not stored inside it. It is somewhere inside the memory. The address is stored inside it. So that's the reason it is called reference or data type. That's the reason it is called reference data type. Okay, that's about string literals. That's about the string literals. Now there is one more literal called null literal. There is one more literal called null literal. Okay, so actually null means nothing. Null means nothing. Okay, so when there is no address, or when there is no reference, then in that case null will be used. Null is actually a literal. Okay, and null is a reserved word. This is a reserved word. We know that, right? Null means nothing. For example, when I say string name, if I don't want to keep any name here, I don't want to assign or write any name here, I can just put it as null. Null means it is pointing to pointing to nothing. It is pointing to nothing. So when it finds null, when your JVM finds null, then for this name variable, no memory will be allowed. Okay, so what it will do is it will allocate the memory. Sorry, it will allocate the memory, and a null will be stored inside it. Null will be stored. Okay, so in case string name equal to null, when I say this, now think that this is your memory. Okay, so now what happens is name is the name of the memory location. Okay, so now directly the value null will be stored here. Directly the null value will be stored because there is nothing, there is no character array that is created here. There is no character array that is created here. Null is means it is pointing to nothing. It is pointing to nothing. Okay, so null is a literal or it's a reserved word when you don't have any references to point. Right? Then you will declare them as null. Well, you will declare as null. In such cases, okay, directly the null value will be stored inside the variable, not just inside the string. Since it is for every reference type, every reference type, every user defined type, the default, if you remember, for every reference type, the default value will be null. Default value will be null. For example, car C is equal to null. I can write something. Okay, or cat C1 is equal to null. Okay, or house H is equal to null. So which means I'm not pointing to any house, I'm not pointing to any cat, and at the moment I'm not pointing to any car also. I'm not defining any car, I'm not defining any cat, I'm not defining any house. For now I'm not defining, but maybe in future I can define it. Okay, I can create it. Okay, today I may not have a car, somewhere in future I might have a car. So today I may not have my own house, somewhere in future I can have my own house. Right now when I say this is my goal to create a house and I don't have any house, I can keep it as null. I can keep it as null. Null points to nothing. There is no memory allotted for, there is no memory or, okay, the value stored inside the memory. That is what it indicates, null. Okay, that's about null literal. That's about null literal. Okay, so so we have covered all the literals. We have covered, okay, char literals, Boolean literals, integral literals, right? We have covered integral literals. Then we have covered floating, string, and null literals. Null literals. All the literals we have covered. So any questions do we have on this literals topic? So with this, if you know, if you understand this concept, we have learnt one single line of code. What is that? Okay, for objects, okay, to define the properties or to identify the properties, to identify properties, we need variables. We need variables. And inside variables, we can store, we store values. Okay, we store values. So for example, int a is equal to 20. We learned this line, one single line of code. So we know data types, we know what is a variable and what is a value. What is the value, right? So if I define final, this will become a constant. This will become a constant. If I define it as a static int a, then this is common for every object. Common for every object. If I don't define static, if I just define int a equal to 20, so it changes from object to object. Object to object. That's all, right? So we have also learned various type of variables here. So which is like user defined, or which is for user defined, and primitive. That's all. So that's a summary of the variables and the literals. Any questions over this before I start the operators? Any questions? Okay. If any questions, please post it here. I'll take it over at the end. I'll take all the queries at the end. Now let us talk about operators. A new topic, operators. Okay. So the meaning itself says, okay, the meaning of operators. What is the meaning of an operator? Right? What is the meaning of an he operates something. He operates, okay, he does some work, operates some activity. So which means he does some activity. It does some activity, right? Operators, simple to say, these are the symbols. These are symbols or signs, which performs different activities, which will perform different activity. Okay. So when it comes to operators, when it comes to operators, okay. So the operators are divided into three types. The operators are divided into three types. What are those three type of operators is? You have unary operator, and you have binary operators. You have binary operators, and you have, okay, tertiary operators. Sorry, ternary operation, ternary operators. Okay, so there is a unary operator, binary operator, and ternary operators. So operators are basically some symbols or some signs which performs some activity, which will do some activity. So the operators are divided into three categories. One is unary operators, and another is binary operators, and third is ternary operators. Ternary operators. When it comes to, okay, the unary or binary or ternary, what it talks about is, okay, it talks about number of operands. Number of operands. Okay, number of operands. Operands means, for example, if I'm adding two numbers, if I'm adding two numbers, 20 plus 30, 20 plus 30, this plus is an operator. The plus is an operator. So which means it will tell you the plus indicates that it's an addition. It's an addition. So where 20 and 30 are called operands. This is operand 1 and this is operand 2. Okay, this is operand 1 and this is operand 2. So now now unary operator. Unary operator indicates, unary means single. Unary means single. A single operand, okay, a single operand will be used with these symbols. A single operand will be used with this symbols. So there are some special symbols where you use, okay, one single operand, one single operand. Okay, and binary. So when it comes to binary, two operands will be used. Two operands will be used, like operand 1 and operand 2. Okay, operand 1 and operand 2. Ternary. So when it comes to ternary, right? So when it comes to ternary, okay, ternary means three operands will be used. Three operands will be used. Okay, so in case of unary operators, only one single operand, one operand will be used to perform the operation. Okay, binary, two operands will be used for the operation, and ternary, three operations. Three operands will be used for operations. So these special symbols are called the operators, and the one who's participating, the one who's participating in this operations are called operands. Okay, in case of unary operators, only one operand. Binary operators, two operands. Ternary, three operands will be used. Three operands will be used. And now, okay. So let us look at, you know that the operators are divided into three categories based on the operands. Based on operands. Now, how many type of operators that we have? How many type of operators that we have? So which means how these symbols are segregated in Java, how these symbols are segregated in Java. So when you ask me, they are segregated into 10 types. They are segregated into 10 types. The operators or these symbols are segregated into 10 types. Okay, what are those? One is arithmetic operators. One is arithmetic operators. So arithmetic operators, and second is, okay, string concatenation operator. String concatenation operator. Third is assignment operator. Fourth is increment, or and you can say increment or decrement operators. Okay, increment or decrement operators. Then fifth is relational operators. Relational operators. Sixth is Okay, logical operators. Seventh is a new operator. New operator. Okay, then instance of eighth is instance of operator. Instance of operator. Ninth is conditional or ternary. Ternary operator. Okay, last is bitwise operators. So there are, okay, based on the operands, okay, either you can define it as a unary operator or binary operator or ternary operators. Ternary operators. Actually the operators are of 10 types. So when it comes to arithmetic operator, it can be a unary, it can be a unary or binary. So which means only one single operand can participate in the arithmetic operation, or maybe two operands can perform in arithmetic operations. Okay, something like when it comes to ternary, here three operands will be used. Okay, when it comes to bitwise, always these are binary. So two, logical two, relation two, right? Increment, okay, unary, single, okay, assignment, okay, assignment two, or this can be single, something like this. Okay, string concatenation two, right? So the number of operands, okay, each arithmetic operator, when you take arithmetic operators, right, arithmetic operators can be of unary type or binary type. You can perform unary operations and binary operations. Basically you can have one single operand or you can have two operands. When it comes to string concatenation, you will have two operands. When it comes to assignment, okay, you will have one single operand, or you will have two operands. Okay, when it comes to increment and decrement, okay, you can increase a value or decrease a value, which is one unary. Relationship, relational operators tells you the relationship. Okay, it will tell you the relationship, so which is binary. So logical operators always binary, at least two. Okay, new operator, new is one single operator, it is unary. Okay, instance of, it will take two operands. Conditional, which will it is conditional or ternary, three operands. Bitwise, again it takes two, it takes two. Okay, so it can be of any type. Okay, so you know about arithmetic operators, right? So basically the arithmetic, we'll talk about the arithmetic operators now. The arithmetic operators used to create an arithmetic expression. Arithmetic, these operators are used to create an expression, arithmetic expression. Okay, so what is an expression? What is an expression? Basically, okay, basically you will have two operands or a single operand, okay, combined with the operator, so which will frame a expression. For example, when I say int x is equal to 20 plus 30, 20 plus 30, okay, 20 plus 30. Now this 20 plus 30, is called as a expression. So since this expression is framed with the help of an arithmetic operator, this is called arithmetic expression. Arithmetic expression. Okay. So in arithmetic operators, okay, in arithmetic operators. So either you can use a numeric type, either you can use a numeric type, or you can use a character also. You can use a char type. To perform an arithmetic operation, you can use numbers, or characters. You can use numbers or characters. And do remember, always result will be int or wider than int, wider than int. Okay. So for example, when I define byte byte b is equal to 10, okay, byte b1 is equal to 10, or b1 is equal to 20, b1 equal b byte b equal to 10, b1 is equal to 20. Now when I say byte b2 is equal to b plus b1, b plus b1, so I'm adding these two values. So what is the value inside b? 10. So this will be 10. Inside b1 it will be 20. I'm adding 20, 10 plus 20, 10 plus 20. Now ideally we should get byte b2 is equal to 30. So when I print b2, I should get the value as 30. I should get the value as 30. But there is one problem. There is one problem. What is the problem? After this evaluation is completed, after this evaluation is completed, your JVM will expect the other type. Okay, the value what you're going to store inside B2, the value what you're going to store inside B2, the data type must be either int or wider than int, wider than int. So do remember the table. So always you should remember this table. So what is the first? Byte, then short, then char, then int, long, then float, then double. Okay. So any arithmetic expression that you are trying to that you are trying to evaluate, once the result is generated, okay, it expect the data type that you are going to store it as an int, as a int, because int is the default type. Int is the default type in Java. It is the default type in Java. Now, when I say b plus b1, I'm doing an arithmetic operation. So this value will expect, okay, this value is expected to store inside an int type data. And when we store inside byte type data, your compiler will throw an error. Compiler will throw an error. Reason is the result is expected to have either integer or greater than integer, wider than integer types, wider than integer types. Okay. So what are the arithmetic operators that we have? So you know that plus minus, multiplication, division, right? Modulus. All these are, all these are, all these are, you know, the arithmetic operators. All these are the arithmetic operators. Okay. So plus means addition, minus means subtraction, multiplication, then division. This is for remainder. This is for remainder. Modular we call. This is to get the remainder value. Okay. So the result of any, when you are using any of these operands, when you are using any of these operands, the default result, it will expect you to have it as an integer. So you can store only inside integer type or greater than integer type, greater than integer type. Okay. Okay. So let me showcase one example for this. Let me go to the code. Let me go to this PC. I'll go to practices. Let me create a new class. This time the class name I'm giving it as arithmetic check. The class name I gave it as arithmetic check. So here I'm defining two variables. One is byte b is equal to 10 and another is byte b1 is equal to 20. b1 is equal to 20. Now, so I wanted to add the variable b and b1, the variable b and b1. So now I am defining byte b2 is equal to b plus b1, b plus b1. So here I am trying to add, I'm trying to add, okay, byte type data, byte type, two byte type variables, and I'm trying to store that inside b2. I'm trying to store that inside b2. But the thumb rule that we know is the arithmetic operator, the arithmetic operator by default it will pick int type data. The result will be the result the result will be int type. Result will be int type, and it expects the data type as integer, and it expects the data type as integer. But here I'm having byte. I'm having byte. As per the table or as per the chart that we have, okay, byte is lower type when you take it when you compare integer. Okay, as per this chart. So byte, short, char, and int. So which means char, short, byte are less than integer. So it expects by default int or longer than int or longer than int, not less than that, not less than that. So now in this case, my compiler sees that he's doing a arithmetic operator, but the result type is integer. The result what it generates is of integer type, which I'm storing inside lower data type, and my compiler will give a problem here. I'll save this. Let me copy this class name. I'll save the class. So now I'll try to compile it. Java C arithmetic check dot Java. You see now incompatible type, possible loss of conversion from into to byte, it says. I didn't define anywhere. Right? Maybe assuming that these two lines is creating a problem, right? I'll just try to remove that. These lines I deleted. Now I'll try to compile it again. See, it says that you are doing an arithmetic incompatible types. Okay, possible loss of conversion from into to byte. So I'm not saying that. I'm not saying anything that this is of integer type. This is of integer type. So your compiler knows that there is a rule that when you're defining or when you're using an arithmetic operation, the default data type that it picks as integer. Okay, and you can have either int, either you can store that either inside int or wider than int or wider than int. So for example, here now I'm using byte which is of lower type, so it is giving the problem. It is giving the problem. So which means internally, your compiler is checking for, is trying to do some conversion. It is trying to do some conversion. So as per the conversion, the default type is int, and from you're going from int to byte, you're going from higher to lower. So there is a chance of data loss. It is telling you there is a chance of data loss. So either you make it as int or greater than int. So if I make this as int, I'm happy. The rule is satisfied, compiled. The code has been compiled. Or longer than int. I can have it as long. Long is as per this table or as per the chart that we have. Okay, long is greater than int. Long is greater than int, or float is also greater than int. Double is also greater than int. Any of these are allowed, but not less than that. But not less than them. So now let me try to compile, happily compiled. But if I define it as a char, which is of lower type, now again, it gives the problem. It gives the problem. So arithmetic, the result type always will be of integer type. always of integer type or wider than integer type, wider than integer type. Okay, so not just plus, you can use minus. Okay, any of these operators. Okay, any of the operators, or star, which is a binary. So now these are binary operators, right? This is arithmetic operators are binary type because two operands that I'm using. Two operands I'm using between the symbol, between the multiplication symbol. So two operate, these are binary operands or binary operation. So now I'm trying to, I'll clear the screen. I'll try to compile this. You see, I still have the problem. So by default, it will be of int or wider than int. That is one thumb rule to remember. One thumb rule to remember. Okay. What if one operand is byte and another is is of long type? Another operand is of long type. So now, since I'm using a binary operand, okay, since I'm using a binary operand here, I'm doing a binary operation, or maybe an arithmetic operation. I'm doing an arithmetic operation. Either it can be of int or longer than int type. So now here, one of the operand is of long type. So this should be, the result will be of long type. The result will be of long type. Okay. So the arithmetic operators by default, if you are using lower value, if you are using lower types, then default will be int. If any of one operand is of long higher type, if any of one operand is of higher type, then the result will be higher type. So now if I make it as int, I'll get a problem. I got a problem because now the result it has generated as long. Now the result it has generated as long. Okay. So these are the rules for, these are the rules for arithmetic operators. Arithmetic operators. Okay. So I'll write down everything. Just try to note it down if possible. So what are the arithmetic operators that we have? Plus, minus, star, okay, division, and modular. This is called add, addition, subtraction, multiplication, division. This is called as, okay, modulus, where you get reminders, where you will have reminders. Okay. So when one comparison, I'll say one comparison. Okay. Result will be by default int in case of lower types, lower type operands. In case of lower type operands, when you're using lower type operands, then the result will be int. Then the result will be int. Okay. Result will be longer type if any of one operand is higher type. Okay. Result will be all long type means high, wider type. You can take it as long means wider type. Okay. In case of higher type. So here is the table. For example, when I have operand 1 and operand 2, okay, and I'm performing a arithmetic operation. Arithmetic operation result. Okay. If the operand 1 is of char type and operand 2 is also of char type, fine. The result will be integer. So you have to remember the table: byte, short, char, int, long, float, double. This is the order as per the order. Okay, it's the ascending order. Okay, it's the ascending order. So char and char, the result will be int. Okay, so byte and char, result is int. Byte, byte, int. Char, short, int. Result is int. So any combination between these things. So short, byte, int. Short, short, int. Int, int. Then also int. Okay, char, int. Char and int. Result is int type. So because int is big wider one. Int is wider one. Similarly, you have int byte. Result is int. Now int long. So long is higher type. Long is higher type. I'll write it here again. Byte, short, char, int, long, float, double. So you look at long is higher type. So when it comes to int and long, since one of the operand is of long type, the result is long type. Long, int, long. Float, long. Now you see float is of higher type when it compared to long. So then the result will be float. Okay. So float, float. Result is float. Okay. Result is float because both of the operands, any of one operand is higher type, then the result is of the same type. Similarly, float, double. Float, one operand is float type and another is double. Double is the topmost priority. So the value will be of double type. Double, double. Value is double. Double, char. So it's of double type. So the result is double. So wider type, if you have any of one operand is of wider type, if any of one operand is wider type, the result will be of the wider type. The result will be of wider type. Okay. If you are framing, okay, with any of this byte, short, char, the default result will be integer. Default result will be integer. Okay. That's about arithmetic operators. Increment and decrement operators, how many operands? So it is unary. Increment and decrement will have unary. They are called as unary operators. It will have one operand. It will have only one operand. We'll discuss that. So any questions on arithmetic operator? Four simple rules. So basically arithmetic operators can be of unary type or binary types. And okay, so but default result will be of int type. Default result will be of int type. And if any of one operand is higher type or one of any of one of if any of one operand is of wider type, the result also will be of wider type. That's it. Okay. Any questions on this? Any questions? I hope I answered this question. You will have only one operand for increment and decrement. We'll see that. Assuming there are no questions, okay, we can take a break. After 7:30, we'll take a break for 30 minutes. From 8 to 9, we'll continue the session. I'm sharing my screen again. Just confirm if you can see my screen now. So assuming that my screen is visible. So we discussed about arithmetic operators, right? We discussed about arithmetic operators. Now we'll discuss about the second operator, which is called string concatenation operator. String concatenation operator. Okay. So basically it's a binary operator. It's a binary operator, which means there are two operands. There are two operands. So so there is one symbol or one sign which is overloaded in Java. There is one symbol or one sign that is overloaded in Java, which is called plus symbol. Okay. So the plus symbol is overloaded in Java. So overloaded means it changes its behavior. It changes its behavior. So, okay. So the one operator which is overloaded in Java is the plus operator. Okay. So when both operands are of integral type, when the both operands are of integral type, then the plus will behave as arithmetic operator. It will behave as arithmetic operator. If any of one operand is of string type, then the same plus operator will act as string concatenation operator. String concatenation operator. Okay. Okay. So string concatenation operator, the plus symbol is called as string concatenation operator. So the plus symbol is also called as an arithmetic operator. So using plus, you can do an addition, right? You can do an addition. But to add two numbers, both the data types or both the operands should be of integral types. If any of one operand is of string type, then this plus operator will behave as string concatenation operator. It will behave as string concatenation operator. Okay. So what is mean by concatenation? What it mean by concatenation? So concatenation is like combining two strings. Combining two strings. Okay. In case of arithmetic, we know that the default result will be of int type. Default result will be of int type. Now when it comes to concatenation, string concatenation operator, okay, when it comes to string concatenation operator, okay, now string concatenation operator will return the result as string. It will return the result as string type. For example, so when I say 90 plus 9, for example, when I have an example which is called 90 plus 9, both are of integer type. Both are of integer type. So the result will be 99. The result will be 99. So in this case, now plus symbol will act as arithmetic operator. It will act as arithmetic operator. Okay. But now there is something called, I am defining 90 inside double quotes. So which means I am representing this 90 as a string now. It is not a number anymore. It is a string plus 9. So one of the operand is of string type. Now it will combine it. Now the result will not be 99, it becomes 909, and this is of string type. Whatever that you give, it will add to this string. It will add to the string, and it will convert to string type, Maybe 9 plus 90, this also become 909. Or something like this. 90 plus 9, 909. Here it is of string type. So whatever you add, it gets added into the string. Okay. So in this, when both the operands are of integer type, then it behaves as an arithmetic operator. If any of one operand is of string type, then it will behave as string concatenation operator. The plus operator will behave as string concatenation operator. Okay. Always that when you are using a string concatenation operator, the result will be of string type. Okay. For example, when I have first name, okay, which is of string type, when I have string of last name, okay, something like ABC, okay, EFG, something like this. Okay. When I say string full name, okay, so then I can say first name plus last name. So now it it becomes ABC plus CFG, EFG. So the result will be ABC, EFG. Now this plus operator will behave as string concatenation operator. Okay. Okay. So that's about string concatenation operator. Nothing much. Okay. So the next operator, we'll look at the next operators, what we have. So we covered arithmetic operator, string operators, assignment operator. So when it comes to the assignment, okay, equals. The equal symbol is called as assignment. Equal symbol is called as assignment operator. basically it will assign some value, which means it will store the value inside the variables. Okay, equals operator is called as assignment operator, which will store the value inside inside a variable. For example, a is equal to 20. A is equal to 20. Now, when I say equals, this we are saying we are assigning the value of 20 into a. We are assigning the value of a into a. So when I say int a equal to 20, here equals operator is called as assignment operator. Okay. So using equals operator, we will store the values inside the variables. So which is called assignment, variable assignment. Okay. That's an assignment operator. Always, always, okay, the assignment will happen from, okay, right to left, right to left, not from left to right. Assignment will happen from right to left. So, so now if you see, it is of binary. Ideally, it's of binary. Okay, because you have two operands. You have two operands. Okay, between equals, there are two operands. Or sometimes this can be an expression, an assignment operator. This can be an expression. For example, a is equal to 20 plus 30. I can write something like this. So in this case, you cannot treat a, or a is one operand, b is another operand, c is okay, 20 is another operator, and 30 is another operand. Nothing like that. So what it does is, first it will do the operation first. First it will do the operations, and the assignment will always happen at the end. Okay, operation will execute first, will execute first, and assignment happens always. Assignment will happen always at last. Okay, so when it comes, when there is an expression on over here, so now first this operation will be executed, and then the assignment will happen into a. Okay, so there is no specific result type for assignment operators. So using assignment operator, will store the values inside the variables. Will store the values inside the variables. So that's all about assignment operators. Okay. Now, so the increment or decrement operators. When it comes to increment, sorry, sorry. Uh, so increment operators. We're discussing about increment operators or decrement operators. Increment or decrement. So when it comes to increment or decrement, okay, when it comes to increment or decrement, there are two type of increment or decrement operators. One is pre and another is post. Pre-increment and post-increment operators. So increment operators are divided into two types. One is pre-increment or decrement, pre-increment or decrement. Post indicates post increment or decrement operators. Okay, so the increment means add by one. Decrement means, okay, subtract by one. Subtract by one. Increment means add plus one. Add plus one to the value. Decrement means add minus one to the value. Add minus one to the value. Okay, these are like unary operators. These are like unary operators. So the pre or post. The name indicates pre or post. So the increment operator, what we have is plus plus minus minus. Okay. The double plus is called as increment. The double minus is called as decrement. The double minus is called as decrement. These are the increment or decrement. Okay. So based on these positions, based on the positions that you define for the operator, that becomes a pre or post. That becomes a pre or post. Okay, plus plus and minus minus are called increment. Plus is called increment, plus plus is called increment, minus minus is called decrement operator. It is called decrement operator. So based on the position, when I say pre, it comes in the front, it is suffixed. Okay, post means it is prefixed for the operand. Post means it is prefixed for the, okay, operand. Suffix and prefixes. Okay, pre means prefix. Okay, post means suffix. For example, now if I take I equal to 10, a value called I equal to 10. So now when I say plus plus I, plus plus I, so the position at the front, okay, the position is defined at the front. This is pre-increment. This is pre-increment. When I define after, suffix it. This is post-increment. This is post-increment. Okay. Similarly, okay, decrement, minus minus I, pre-decrement. I minus minus, post decrement. Okay, so what is the difference between plus plus I and I plus plus? I plus plus. So when I say plus plus I, when I say plus plus I, this is equivalent to, this is equivalent to 10 plus 1. This is equivalent to 10 plus 1. Now I plus plus, this is also equivalent to 10 plus 1. This is also equivalent to 10 plus 1. Okay, what is this pre and post decides is, okay, the value of assignment. The value of assignment. When the value will be assigned? After performing the operation or before performing the operation? Okay, for example, when I say I is equal to 10, okay, I1 is equal to plus plus I, plus plus I. So now this plus plus indicates, okay, this plus plus indicates when the value will be assigned into I1. Is it first it will assign it, then the operation will be performed? Okay, when the operation is performed, or after performing the operation, the value is assigned here, right? So the increment pre or post will decide when the value will be assigned into I1. That is what it decides. So when I say plus plus, first the value, okay, pre increment in case of pre increment or pre decrement, pre decrement. In case of pre increment or pre decrement, first value will be assigned. First value will be assigned. So which value, what is the value inside I, that will be assigned into I1. That will be assigned into I1, right? Simple to say. So pre-increment first, sorry, in case of pre-increment, in case of pre-increment, first execute the result. First execute the expression. In case of pre, sorry, I was thinking about post. Okay, in case of pre-increment, in case of pre-increment, first increase the value. First increase the value and then assign it, and then assign it. Okay, there is a small confusion here. In case of pre-increment, in case of pre-increment, first increase the value. First increase the value, then assign, then assign. First it will increase the value and then it will assign. Okay, so which is like pre. It is the same in the case of pre-decrement also. First decrease the value, First decrease the value, then assign, then assign. So when I say int I equal to 10, int I1 equal to plus I, first it will increase the value and finally the result will be evaluated, then it will assign it to us. So this statement internally will be split into something like this. I1 is equal to I plus 1, I plus 1. So I plus 1 value will be I1 is equal to 10 plus 1. So the result will be evaluated and it will assign that value. It will I1 value will be 11. I1 value will be 11. Okay. So let us check that. Let us check that. So I'm taking the same class. I'm not changing the class name. Here, the same example I'm taking, int I is equal to 10. Int I1 is equal to, first I'm doing plus I. Plus I. First it will increase the value. It will increase the value by 1 and then it will assign it. Then it will assign to I1. So now I1 value should be 11. So the I value will be 10, right? I value will be 10 and I1 value will be 11, right? So ideally what it does is it will increase the value of I also here. It will increase the value of I also. Now it will increase the value of I by 1 and then it will assign the value to 1, I1. So for example, if I try to print I value, if I try to print the I value, that's a beauty. So I value will be increased by 1 and then I1 value will it will assign the value to I1. So now if you see I value will be 11 and I1 value also will be 11. Both values will be the same. Compile the code. Both will be 11. So now you see the I value also it is increased by 1 and and that value it is assigned to I1. Okay, that value it is assigned to I1. So pre-increment happened. Now when I say pre-decrement, I value will be decreased by 1 and that will be assigned to I1. That will be assigned to I1. So now both values will become 9. Both values will become 9. Sorry, compiling the code. Both values will become 9. So what happens is in case of pre-increment or pre-decrement, first the value will be increased or decreased by 1, then the value will be assigned to the other variables. In case of post, in case of post, in case of post, first the assignment will happen, then the increment happens. First the assignment happens and then the increment happens. In this case, first the assignment, I value what is there, it will assign to I1, then I value will be increased by plus 1. I value will be increased by plus 1. So now in this case, I value will become 11 and I1 value will become 10. I1 value will become 10, which is like post. So post means the operation executed at the end, first the assignment happens. Reverse of pre. Reverse of pre. Trying to compile the code, executed. You see now, I value is 11. Okay, I value is 11, but I1 value is 10. I1 value is 10. Okay, so simple thing, pre-increment. Okay, In case of pre-increment, first increase the value, then assign, then assign. Okay, or first decrease the value, then assign. Okay, opposite of post. Post is first assign. In case of post, first assign, then either increase or decrease. Increase or decrease the value. Okay, so that is the difference between pre and post. Okay, pre-increment, first thing it will increase the value, and assignment will happen at the end. Assignment will happen at the end. Okay, post, first it will assign the value, then the increment will happen, then the expression will be executed, then the expression will be executed. Okay, the opposite of pre is post. So based on the, so the plus plus and minus minus are called pre, okay, increment operators. Plus plus is called increment, minus minus is called decrement, based on the position that you apply. Either if you apply in front of a variable, or in front of any value, okay, that becomes pre. After, if you define, okay, prefix, if you make it as, it becomes pre. Okay, suffix, if you make it as suffix, then it becomes post. As simple as it. Okay, so I plus plus, I plus plus becomes post, plus plus I becomes pre. This is post increment, this is pre increment. In this case, assign first, then increase. In this case, increase first, then assign, then assign. Okay, so I minus minus, post decrement. So in this case, assign first, then decrease. Minus minus I, pre decrement. Decrease first, then assign. I hope this is clear. Okay, so actually for which variable that you are using, or for which value you are using, that value will be increased or decreased. Okay, that value will be increased or decreased. For example, in my case, I am taking int I equal to 10. This value will be increased or decreased. So I plus plus, plus plus I, or I minus minus, minus minus I. Okay, so it will have one single operand. It will have one single operand. Okay, this is about increment or decrement operators. So when I say int x equal to 20, int x equal to 20. Okay, now long y is equal to plus plus x. Long y is equal to plus plus x. Now what will be the value of y, and what will be the value of x? What will be the value of y, and what will be the value of x? Can someone tell me what is the answer for this? So identify whether this is a pre or post increment operator based on the condition that we have written. Okay, tell me the value of x and tell me the value of y now. Can you give me the answer for this question? as per the rule, int x equal to 20, long y equal to plus x, long y equal to plus x. What is the value of y and what is the value of x? Simple rule. So initially x value will be 20. Initially x value will be 20 and y doesn't have any value, so it has to perform some operation here, which is plus x. Plus x indicates, okay, it's a pre-increment, right? Plus I, it's a pre-increment operator. So first it has to increase the value, then it will assign. So first it has to increase the x value by 1. First it has to increase the x value by 1. So this becomes x is equal to, okay, x plus 1. This becomes x equal to x plus 1. So now x value is 20, 20 plus 1. So x becomes 21. X becomes 21. So first the value will be increased. So the x value becomes 21 and this 21 will be assigned to y and this 21 will be assigned to y. So x value will be 21 and y value also will become 21, right? X value will become 21 and y value also becomes 21. Okay, let us check this. X and y. Y is of long type. Y is of long type. So I'm making it as plus x, plus x. So here I'm printing x value and y value. Printing x value and y value. Compile the code. Execute. X value is 21 and y value is also 21. Okay. So that's about arithmetic operators. That's about increment or decrement operators. Increment or decrement operators. Similarly, you can do that for, you can apply for post increment. Now, for example, I have int x equal to 20 and I have int y is equal to x plus plus, x plus plus. So in this case, first assign the value, it is post increment. So assign first, then increase. Assign first, then increase. So x value is 20, x value is 20. So what it does is, okay, x plus plus indicates y equal to x plus plus. This indicates, okay, y equal to x, y equal to x. First it will do y equal to x and then, okay, x equal to x plus 1. It performs this operation. It performs this operation. So, so in this case, y equal to x. Y equal to x means what is the value inside x? 20. So y equal to 20 and x value x equal to x plus 1. X equal to x plus 1. X value is 20. So 20 plus 1. X value will become 21. So here x equal to 21 and y equal to 20. So this is what it mean by post and pre. Okay, first the value will be assigned, then the value will be increased. First the value will be assigned, then the value will be increased in case of post. In case of post. Okay, so if you remember this, if you know this, this is an arithmetic operation. This is an arithmetic operation, right? So plus is an arithmetic operator because the operands that we are applying it for, integral types. Okay, result will be int or wider than int. Result will be int or wider than int. The same rule applies. Like arithmetic operator, the same rule applies over here also. Okay. internally it performs the arithmetic operation. So the result will be either int type or wider than int type, wider than int type. So in this case, int, the result what it generates is of int type. What it generates of int type. I cannot store lower than that. I cannot store lower than that. For example, so here int and long, int and long, even though I'm using single operation, I'm internally it does a arithmetic operation. So x plus it is using x plus is an arithmetic operator, plus is an arithmetic operator because both the operands are of integral type, both the operands are of integral types. So the result will be okay, either int or long or wider than that. If I store that inside log, inside byte, which is lower type, which is lower type, now you see you get possible loss of conversion. Internally it does the arithmetic operation and it generates the integer as the result. The integer as the result. The integer result you are trying to store inside byte. So that's about increment or decrement. It applies for both increment or decrement, pre or post, whatever it is. So relational operators. The relational operators, these are like, okay, these are like you can say as comparison operators also. These does the comparisons. So the relational operators tells us the relation between the operands. They'll talk about the relation between the operands. What are the relation of operators that we have is less than, greater than, less than or equal to, greater than or equal to, not equal to, not equal to. These are relational operators. So these are basically binary operands. These are binary operands. So if I want to do a comparison, if I want to tell a comparison, okay, so I need two operands. So a less than b or b greater than a, b greater than a, okay, a less than or equal to b, okay, b greater than or equal to a, okay, a not equal to b. I have to tell something like this. So which is explaining the comparison between the operands, which is explaining the relationships. So always the relationship operators, the result type will be of Boolean. It will either generate true or false as a result. True or false as result. It will generate either true or false as result. Nothing apart from that. Okay. For example, if I say int a equal to 10, int b equal to 20. So when I'm trying to print a greater than b, I have to say yes or no. I have to say yes or no. Now 10, then here, as per this comparison, 10 greater than 20, 10 greater than 20. So which is not a valid case. No, 10 is not greater than 20. So we'll get the output as false. So when I say a less than b, a less than b. So 10 is less than 20. So in this case, I'll get true as the result. Okay. So now a value equal to 20 and b value also is equal to 20. Now I can say a is greater than or equal to b. Either a is greater or equivalent to b or equivalent. There is a same that greater or, there is another condition or condition. Okay, greater or equal. So now 20 is not greater, but 20 is equivalent to 20. So this will return true. So one condition failed, the another condition succeeded. Okay, greater than or equals. Similarly, okay, a less than or equal to 20. A is a less than or equal to b. So which means 20 less than or equal to 20. So 20 less than 20, not, it will not execute. Or 20 equivalent to 20. 20 equivalent to 20 is success, which means it will return true. There are two condition evaluation. 20 is not less than 20, but 20 is equivalent to 20. So any of one condition, either it should be a small or equivalent value, greater or equivalent value. something like this. Okay, which is also called comparison operators. So in this case, when I take int x equal to 20, okay, now I'll take byte b equal to 30, byte b equal to 30, x greater than y, I'll say, and I'll say in the second case, y greater than x, y greater than x. So now I have a variable which is of x is of integer type, y is of byte type. So x contains the value 20, y contains the value 30, x greater than y. So 20 greater than 30 I'm saying here, and here I'm saying 30 greater than 20. So let us see the result what it generates. First, let us try to compile the code. Code has been successfully compiled. So first case it says it has written false, and second case it has written true, right? So 20 less than 20 greater than 30, not correct. So it has generated false as the output. Here 30 greater than 20, it has generated true as the output. So always the comparison operators or the relationship operators generates the Boolean type as the result. Boolean type as the result. So the next operators, what we have the next operators, let me go. So logical operators. These are very interesting operators. The logical operators are binary operators. The logical operators are binary operators. Binary operators. Okay. So when it comes to the logical operators, okay, when it comes to logical operators, these logical operators executes based on truth tables. These will get executed based on truth tables. Okay. So what are these logical operators? What are these logical operators? So how many of you know that the logical operators? Just for a check. How many of you know the logical operators? No one knows about the logical operators? Okay. So the logical operators that we have is and, or, not. And, or, not. Okay. So maybe you are aware of not. I'm not sure. These are called logical operators. So the symbols that we have is double and, double line, double pipes, which is called for or and not. Okay. So there is a truth table for each of them. There is a truth table for each of them. So for example, if you have operand 1 and you have operand 2 and there is a result it generates. Okay. If you know about this, then fine. If you are not aware of this, this is how the truth table. This is how the truth table. Okay. If both in case of and, if both operands are true, okay. If the both operands are true, then the result will be true. If not, if any of one operand is false, then it will be false. So if first operand is true and second operand is false, the result will be false. Now the first operand is false, the second operand is true, then also the result will be false. If both operands are false, then also false. So the operand can be, okay. So the do remember the logical operator only take the Boolean values as input. It will take the Boolean values as input, either true or false, either true or false as an input. So this can be an expression also. This can be an expression also. For example, I can say int x equal to 20, int y equal to 30, y equal to 30. So I am trying to print now something like this. Okay. So x is less than y and y is greater than x. Y is greater than x. So now in first case, okay, x is less than y. So it is completely taken as one single operand, because first it will perform the first it will perform the expression, and the result will be taken as the operand. So x is less than y. So 20 is less than 30. The value is true. The value is true. And 30 is greater than 20. 30 is greater than 20. This is operand 2. This is operand 2. So y is greater than, which means 30 is greater than 20. So this is also true. This is also true, right? System.out.println of true and true. So now you see that, okay, as per the truth table, okay, when the what is the result, it decides. If both the operands are true, if both the operands are true, the result is true. The result is true. So in this case, the output will be true. The output will be true. So now something like this. I am changing the condition. X greater than y and y greater than x. I'm just saying SOP system.out.println of x greater than y and y greater than x. So now here I'm saying 20 greater than 30 and 30 greater than 20. So in this case 20 greater than 30, which returns false as an output, and 30 greater than 20, which returns true, which returns true. As per the truth table, if any of one if any of one operand is false, the result will be false. Here the result will come as false. That's about logical AND. Logical AND. So we'll verify this example also. So I'm taking x equal to 20 and byte y is equal to 30. Now here, instead of writing in two lines, I am writing something like this. X greater than y. So first I'll say x less than y. X less than y and y greater than x. Y greater than x. So now you see x greater than y. First it will execute this. So x less than y, 20 less than 30. This will return the value as true. And now 30 greater than 20. 30 greater than 20. So when I say 30 greater than 20, so this will also return true. As per the truth table, if both operands are true, then the result will be true. Then the result will be true. So let us verify this. Code has been compiled. The result is true. The result is true. So so now I'll change the condition to greater. So now I'm saying 20 greater than 30, 20 greater than 30 and 30 greater than 20. So 20 is not greater than 30. This will return evaluate the value as false. This will evaluate the value as false. False and true. So as per the truth table, so when any of one operand is false, the result will be false. So again trying to compile the code, executed. I think I didn't save this code. Now the value is false. Previously I didn't save the code, so you got the old code or old result. After saving it, you see 20 greater than 30, which is false, and 30 greater than, which is true. As per the truth table, it became false. Okay, so that's about the logical AND. Logical AND. What about logical OR? Logical OR also has a truth table. Logical OR operator. So which is like double pipe, which is like a double pipe symbol. So when it comes to logical OR, so this is how the truth table. Operand 1, operand 2, and then the result. If any of one operand is true, then the result is true. Completely opposite of AND. Okay. If any of one operand is true, for example, first operand is true, second operand is false, this becomes false. Okay. Or if first operand is false, second operand is true, then also it becomes true, because any of one operand is true. Okay. If both operands are true, then also true. So when it returns false, if both operands are false, if both operands are false, then it will return false. Then it will return false. So now the same example, if you take, instead of and, use a double pipe. This is logical OR. This is logical OR. So x greater than y, which means 20 greater than 30, this returns false. This returns false. Now y greater than x, which means 30 greater than 20, this is true. This is true. As per the truth table, if any of one operand is true, if any of one operand is true, then the result is true. Then the result is true. Let us check that. So as per this logic, it should return true. Now it has written true because I'm instead of and, I'm using or. Any of one operand is true, the result will change. The result will be true. The result will be true. Okay. The result will be true. So the truth table is very important in case of logical operators. Okay. And when both operands are true, then only true for and. Okay. For logical OR, if both operands are false, then only false. Rest of the cases, everywhere it is true. In this, in and, every case it will be false. Every case it will be false. Then what is not? What is not? Not operator. Okay. Not operator will always say opposite result of it. Opposite result of it. Okay. So when I say true, when I say true, then it will say false. If I say false, it will say true. Okay. So for example, the not operator is represented something like this. Not operator is a unary operator. Okay. It takes only either true or false. When I say when this gets false, then it says it is true. Opposite result it will give me. Just trying to compile. See now, 20 greater than 30, I'm saying 20 greater than 30, which will actually return me the value as false. Okay, which will actually return me the value as false. Now, when I say false, it will say true. It will say opposite of it. So for example, when I say x less than y, which means 20 less than y, the result will be true. When the result is true, it will give the opposite of it. Okay, it will say false. Now it will say false. Compile the code. Now it will say false. Okay, so unary not operator. Okay, not operator is a unary operator where it takes only one thing. Okay, when the operand is true, result is false. Result is false. When the operand is false, the result is true. Result is true. These are the truth table for logical logical or and logical not. Logical not. So the new operator. Okay, we'll discuss about the new operator and we'll close. These three operators we'll discuss in the next session. So the new operator. New operator, okay, new operator allocates. This is the operator which will allocate the memory, which will allocate the memory for any reference type, for any reference type in Java. For example, when I want to create a new object, when I want to create a new object in Java, okay, so when I want to create a new object in Java, then without new keyword I cannot create a new object. Okay, so when an object is created, when a object is created, the memory is allocated. The memory is allocated in Java. For example, when I say car of C, okay, there is a class called car or something like this. Maybe let me write one example. When I have a class called car, I want to create an object for this car. I want to create an object for I want to create an object for this car inside Anil, inside Anil class. I want to represent an Anil class and I want to represent this object. So I want to create a new object in Anil. So car C is equal to new of car. I can say something like this. Now when I say new, using this new operator, a new object will be created of car type. A new object is created of car type and that reference will be stored inside the variable C. The variable C. What is this car? You ignore it for now. So the new operator will allocate the memory for it. The new operator will allocate the memory for object C. Object C. So now this class will be initiated. Now this class will be initiated, which means if this class has some properties, all these properties will get memory. All these properties will get memory. So new is the one which will allocate the memory for reference type in Java. So, so when I want to create another object, car C1, so which is of new type, new car. Okay, always, okay, in Java there is a memory space called as heap. There is a memory space called heap. New will always create new will always create or allocate a memory for the objects inside heap space. Inside heap space. Okay, so new operator is the one which will allocate the memory in for the reference types in Java, and where it will allocate inside the memory, inside the heap space, inside the heap space. So think that this is your memory. If this is the memory is divided into, okay, class space and heap space. Class space and heap space. Okay, so in class space, basically all the static content, all the static content static content will be loaded into the class space. For example, the static variables, the static methods, okay, static blocks, it goes into the class space. It goes into the class space. Okay, so the common variables, the common methods, the common blocks goes into the class space. Okay, the object level variables or reference type variables, all the reference type variables, those goes into the heap space. Those goes into the heap space. So now when I say car C equal to new car, when it finds new in heap space, a new memory is allocated for C. A new okay, a new memory is allocated for C. And here, if car has the variables like name, okay, or name, color, something like this, in the heap space, the instance variable memory will be allocated in the heap space. Color XYZ. So when I say car C1 equal to new car, so again I'm calling new. So for C1, there is one more memory that is allocated, okay, and these variables will be placed for that object, name, color, and so on. So this is of C1. If I call car C2 is equal to new car, so now again when it finds new, a new memory will be allocated, okay, and inside this, these variables, name, a copy of it. So here, if you remember, okay, what I have said is instance type variables are linked to the objects. Instance type variables or reference type variables are object level reference type, or instance type, or object level variables are linked to the objects. That is because of new keyword. New keyword. Using new keyword, a new object will be created in the heap space, and all the variables that are okay, that are linked to the object, okay, that are linked to the object will be maintained inside the heap space. So see, new will allocate the memory for the object, and these instance variables are created or allocated inside the heap space for that object. Okay. How many times you call new? Car C3. New car. Now one more. This is C3. Name, color, and so on. So here I can have name as Audi. Here I can have name as BMW. Here I can name as Ferrari. Here I can have as Lamborghini. Okay, here I can have it as black. This is white. Okay, this is in yellow. This is in orange. Something like this. So you see, now for different objects, for different cars, different names and different colors, right? That is possible because of the new keyword. New keyword will allocate the memory. New keyword will allocate a new object. A new object will be created, which means inside the heap space, a new object will be created, which means new memory will be created for that object. New memory will be created for the object. So if I have a static variable, here, okay, so which is like engine, engine type. So that will go into the class type memory. Okay, this is your memory. Think this is your memory. So here, okay, engine type equal to petrol. When I say petrol, so this will be applicable for every car. So these are all, this petrol will be shared with this object. Okay, engine type will be shared with this object. This will be shared with this object. This will be shared with this object. Now, if I change the value to diesel, now every car engine type will get changed. As simple as it. Okay. So new will actually allocate the memory for the object inside heap space. Use without new keyword, you cannot create any objects in the heap space. You cannot create any objects in the heap space, and no memory will be allocated. Okay, no new memory will be allocated for the objects inside memory. Inside memory. That's about new keyword. Any questions? Any questions on this? Assuming there are no questions, so we'll wind up the session here and we'll meet again in tomorrow's session and we'll discuss about the remaining operators. Thank you.